Yo, yo. So I was working on the surge axis, and while it's out of the rig, thought I'd do a rundown on how it's set up. It's a little unique, with the challenge being how do you incorporate the 20 millimeter linear rail and ball screw such that you have a functioning movement of the ball screw, which is pushing on this unit here to this 3D printed part, with the linear slider underneath, which keeps everything in line, and then these end block bearings that support the ball bearing on either side, connected to a spider coupling for misaligned shafts, back down to the servo into a 3D printed base. Idea being, this ball screw is running through the support for the actual actuator. Here it's a ball socket where the bottom of my actuators is a 1-inch full stainless steel ball. This is a half dome socket, like a ball and joint swivel that actuator sits into, and then trolleys along with crankage of the servo. Here it's moving away from the camera, so that would be negative Z. You spin it the other way, it's going to come on towards you. Which that 3D printed part has a little tongue here that connects the ball screw holder to the main body. And that main body has a through hole that allows the ball screw to pass through the unit, with the actual actuator sitting on top of the center line of the linear bearing. So all of the weight transfer from the front of the rig is straight through the top of the bearing, around the casing of the 3D print, this is printed solid 100% ABS, down to the top of that bearing. And when I did print it, I was off by a couple mils, so there's a shim in there that needs to be fixed. These support posts are a little ranky. They were more prototypey, and a threaded rod with a bunch of nuts to make sure that the alignment above is perfectly uniform of the ball screw on center line for the entire shaft. So that's how that works, and it's a little bit hard to see while it's in the rig. While it's out, thought I'd get you a view. Looking at updating the linear rails here to something extreme, almost 7 feet. And I'm concerned it's going to take a little bit of thought on how to make sure that under compression, the ball screw doesn't buckle under rapid movement. And I think the solution is going to be something similar to this, where you can have additional linear bearing blocks along this rail and machine a perfectly cylindrical tube that would slide along the linear rail, similar to this block here, but not with balls inside that would grab onto the teeth here. Just a smooth, very concentric shaft made out of Delrin. And that would be unique because right now the buckling length of this rod is from the face of this bearing, a fixed point, to the face of this bearing, a fixed point, because it's fixed down to this linear bearing. And if you double that, the risk of buckling this under load increases dramatically. So the two options are to get a wider ball screw to have more buckling stiffness, or support it in more points. That support of that Delrin cylinder on a linear bearing at specific locations would be that support. So the ball screw can't move this way, can't move that way, up or down at this specific point, in addition to the main one supporting the actuator. The trick is figuring out how to make those be equally spaced throughout motion of the main actuator's ball screw. I'm thinking like a cable strap, or I don't know how I'm going to do it yet, but I think that's the solution. All right, see ya.